Hello and welcome everyone to day 3 of Power BI Cohort by Mr. Saurabh Sharma. Today we are here to discuss data modeling, and with that I will hand over the stage to Saurabh. Hi Saurabh, thank you so much for joining us.
Yeah, hello Nituma. Thank you. So, hello everyone. So, without wasting our time, let's start the session. So, let me go to the previous lecture, what we learn, what we just a small recap. So, for the day zero, what we have learned is what is the Power BI, what is the tools performance, how can we build some blocks, what is the associations of this, and how do we get the data, how do we create some sort of what is modeling, how to publish the records and all. And also in the day one, he also we have learned something about the visualization side, like what is the bar chart, what is column chart, what is stuck, 100% stuck, combo, cluster, line, area, pie, donut chart, tree chart, and some other card, multi-row card, God chart, KPI, stable, metrics, and some editing, some visuals as well, and how we are differentiating it with the department wise that we have done, right? Moving to the next, which we have completed yesterday, which is the day two. That was the, you can say, the power query. How do we do the data transformation, and how do we remove some missing values, some correction of values, how do we remove some columns, adding some columns, changing the data types, and doing like how do we see the real data in, like how can we preview the data properly so that we can differentiate like whether this is the correct data or not, this is the some sort of a validate data or not, how many errors are there, how many empties are there, and how so we have seen like how do we clean the text data, how do we clean the numeric data, how do we split the columns, how do we change the numerical columns, how do we clean the date column, and some other stuff, right? So this was the pre-cap. So if you don't see any kind of a video or any you can say the previous lecture, you can go to the YouTube, the same link, and then you can see the other lecture as well in the earlier phase. Okay, so let's go to the new one, and today our topic would be the data modeling and table properties. That is very important. If you are familiar with data modeling, then you already know that how do it will impact your decision making basically. Once your data model and your, you can say, semantic model is prepared, then you have to be design your end-to-end flow, and how we can populate one data to other, how one data is impacting to the other, and how we can use this tool to visualize something basically. If your data modeling is correct, your data visualization automatically be correct sometimes, right? Because of your wrong data modeling, sometimes it is not showing you correct data. So this is very important that you have to make sure that our data modeling is correct, and this is very important topic, so that we have to be make sure that how we can proceed. Okay, so let's start from the beginning. So let me start introduce myself. My name is Saurabh Kumar Sharma, and I'm a Microsoft certified trainer and senior consultant at the New Desk Microsoft. Experience in AI and data science. Also, I have completed many certifications, which is already seen. You can see data engineering, DevOps, data administrator, AI fundamental, database administrator, Azure fundamental, SQL, ETL, past side. Also, I have a different kind of a skills as well. Okay, so let's move to the further without wasting our time. Okay, so in the data modeling and table properties, this is our new topic. What we have to do, we have to figure it out how we can model our data, how we can do the complete end-to-end modeling, and what is the data modeling first. First of all, what is the data modeling, right? Data modeling is just like a conceptual view of your data elements, right? What you are thinking about how this data is linked to the another in your mind, you have to picture it out into the Power BI. So typically view of the your data, basically whatever you have, like you have some sort of a tables, column, and some data types, keys. Then the main part is the relationship between tables. Okay, with the example we can see, like this is a business as established table, this is NAICS code table, this is geography table and year table. Let me tell you one by one. So in year table we have mostly date, year, month or something. Month cannot be, sorry, it's a year table, so it should be contain only year, century, decade. And in NACI code table it contains some sort of a code of industry based, right? Geography, we already know the geographical areas. Like if it is country based, then any kind of USA, US or something. If it is, you can say state wise, then depend on which country we have, right? And then this is the main fact table, or you can consider this as a main table. Now, what we have to do is mostly this look like a star schema. Star schema means one table is connected with multiple dimension tables. So here contain the value, which is what is would be the unique value here. So the unique value would be year mostly. So the year would be connected with this year, from this year, from this fact table, right? This one. And here in this year, it is connected with year. Now next is NAICS code star. Here, what kind of a table or column we can require? So you can see here we have 2017 NAICS code, and here also we have 2017 NAICS code. So we can link this together. Now next is the geographical one, right? So here which column we have? Either we can go with ID or geographical area, whichever whatever you have. But here you can see we have only ID. We don't have any kind of a geographical area. So if you want to filter your data based on geographical, but we don't have a column, what we have to do is we have to choose this ID and then link with this ID, so that if the ID is the main part, or you can say the primary key, so that if anything would be changed into geographical areas or something, automatically it will be reflected here because we have mapped properly, right? Now moving to the next one is data modeling. Like if you are processing of the creating of data model, then why the data model would be impacting, right? So if you want to analyze your data, if you want to you can say compress your data, and you want to understand your complete end-to-end flow of your, you can say, modeling side, then you have to go with it, right? Here is one more example. You can see audience target, campaign and agency. So audience target, we have one column audience target ID. Campaign target, we have one common column which is audience target ID. So here this act as a primary key here, and here it is acting as a foreign key. So one primary key is attached with a foreign key. Next is campaign targeting, where the campaign targeting is also a foreign key, and campaign ID is a campaign primary key. So we can attach this here. And now agency is not directly linked with the campaign target. So what we do is the campaign ID is linked with this foreign key. So you have to make sure how many foreign key we have, how many primary key we have. Many times in our areas, mostly in the cases, we are not able to figure it out how many keys we have if there is no key, right? Then what we have to do is we have to create one calculated column or one auto generated of numbers, that kind of a stuff, and then we have to map it properly with the next one. Otherwise the data will not change, right? So we have to be make sure there should be any kind of a primary key, foreign key, or something would be there, right? Now there are some person also there who don't understand what is a primary key and foreign key. Let me clear it out. Primary key is nothing but it's a column basically, which is a unique and distinct for all values, just like a classroom roll number, right? Second is foreign key. Foreign key is just like it is acting as a key, but for other table, not for your table, right? So similarly, like you can say you have a two list. One is burger list, one is pizza list, and in the burger list we have some numbers for each and every burger. And the next table, which is a pizza list, and pizza list contains some numbers for each pizzas, but they are don't not interlinked. If you want to link something, then there should be one burger number should be in the pizza table as well, so that we can easily link that, right? Moving to the next is data modeling in Power BI and Power Query, right? So in Power Query, we can represent the data mostly through the tools, like what kind of columns we required. Yesterday we have learned this, right? So our main goal over there is managing our queries, managing our data, and complete thing, right? So 80% would be through the Power Query, 20% should be from the Power BI. It's up to you. You can change it vice versa. Mostly in the cases in industry, we're directly going with modeling tab and then do whatever we want. But it will not give you, sometimes it will not helpful for you, because most of the cases time there would be some null value, there would be some duplicate value. So it will impact the relationships of that table. So it will not give you the proper solution. But in Power Query, it will helpful, and it will be easy to detect you, like is there any kind of a issue with the columns, is there any kind of a value or some problem with the data, so you can directly figure it out, right? Now columns and row management, that we learned yesterday as well, but there are some operation which is very important for this. So operations means, like operations we have to do in the data side is keep or remove some specific column, right? Suppose you have some columns which is not required, you can remove that one, right? Or whatever column is required, you can keep them. Now next is keep or remove specific rows as well. Similar kind of a stuff. If you don't require any kind of a column, you can delete. If you want that column, then you can take the same one. Now splitting the single column into multiple column, yes, that is the also way. Like if there is a you can say there is some sort of a name or something where we have mentioned some random value, you can split that one. And then last is concate or summarization, or you can say group of row table by contain of column, just like first name last name you have combined into full name, right? So it's a some sort of a values, or you can say the example is also there. They have mentioned like keep or remove column side, removes our empty columns. Keep and remove specific rows. Keep the top rows has a header. That is very important. Third one is splitting a single column, which is DD column, splitting with DD and YY. Three separate columns. And summarizing group row in table by a contain of the column. You can be sum of median of all the rows or something, you can do very easily. Data types. So choosing the data type also essential. Whatever the data type is required, you can easily choose and shape that is required for you. You can choose, there are lots of data type is required, or you can see there are lots of data type we have in the Power BI. So you can take whatever data type is there and then optimize the storage and enable the specific functionality which is being required for this, right? We have hundred of rows, fews of you can say columns, so we have to be make sure that it would be perfectly linked with the another one, right? So we have to be make sure the data type should be correct. Let me give you one example. One column contain dd mm yy, means the date format and the time as well. And second column contain DDMMYY, but time is not there. If you link this one, it will be giving you some errors. Why some error? Not all data is not matching. Most of the cases, if time will little be matched, na, that will consider as a mapping. But most of the cases, the time will not match. That will be a fail of mapping. It will not give you the correct answer. When you apply a filter, the data will not give you the correct option or correct answers, right? So that is the reason what you have to do is every time, if the data type is not correct, it will not give you the correct answer, right? Rounding also very important, right? So Power Query actually change the data, not just formatting. Typically, not right answer. So you can replace with the decimal values one and two. Yesterday we have seen, and in the Power Query side, we can see the data appears how it look like a store, right? One data is only you are rounding off up to two digit, and one data you are rounding off up to three digit. That will also not make any kind of a sense if the data is slightly changing, right? Data mapping means, or you can say power modeling, mapping means correctly mapped data that will give you the right answer exactly, right? Now there is a data set. United States Census Bureau survey data of manufacture. You can see there is a table. Summary of statistics of manufacturing firms basically. North America Industry Classification System, that is called NAICS. Okay, now here you can see in this table we have some areas, some codes, some meaning, some years, some sales. But this is not the single data. This is combination of three tables. Just now we have seen in the previous slide this one. Years, NICS code, start, business establishment, and geography. But here it is showing as a single. Whenever your mapping is working perfectly, your data will be correct. If the mapping is wrong, the data will be wrong. Okay. So let's practice this first, and then we will moving to the next one. So before that, I have some pre-prepared model which we can use for the modeling side. Okay. So introduction of financial analysis. Let me go to. In the meantime, if you guys have any questions, any points, you can ask. Okay. Sneha, good evening. Sneha. Okay. So this is the same one. Now in this one, you can see this table is not linked, the key measures, because it contains some of the measures value only, right? And apart from this, you have one account table, one department table, one organization table, and one scenario table. So most of the cases, we have making this as a star flag schema, and then we are making it look like this diagram. So everyone can understand which one is the fact table. Like this general ledger is the fact table. Another like scenario, department, account, and organization is the dimension tables, right? So what we can do is whenever you importing your data, Then you have to click on manage relationship, new relationship, select which table you want here, select which table you have want here. It will automatically detect one relationship over there. If you want to change, then you have to select and save. Done. Now there are 2 points. What kind of cardinality is here, and what kind of a cross filtering is here? There are four: many to one to many to many. Right? Cross filtering side, single or both. Let me give you one example. Like how can we say which one is the many to many and which one? Mostly we have learned this in the 12th class, uh, like function side. So let me give you some simple stuff so that we can easily understand what kind of a one to many and many to one relationship we have, right? So suppose here we have one called father and we have here son, right? Son, let it be son 2. So very simple question. What kind of relationship this? Like if you draw a line over there, so one father can have two sons. And suppose if there is a daughter as well, then father can have son and daughter. So this would be like a child, and this would be like a parent, right? So for the parent table and for the child table, you can say one father can have three children, right? So this would be acting as this. We, if it is many, then we act as a star, and if it is a single one, we can just write a one. So it would be one to many relationship. Very simple, right? In a single word. Now let's go to the next. Let's see. This is very clear, right? If you have anything, you can ask. Okay. Now let's move to the next one. What is the next? Now let me give you one more. This is one to many or many to one. That was right. One to many or many to one. You can consider with the reference of child. That was many to one, and with the reference of parent is one to many. So 2 points clear. Now next is many to many and one to one. Right. First one to one. Like here we have husband and here we have wife. So I'm only considering at the India level, so don't take personally. So with one husband we have one wife. Simple, right? So that can be one to one relationship. Here we have one, here we have one. Simple relationship, one to one relationship. Okay. Now moving to the next one. So you can say it is completely one to one relationship. Nothing would be there. Now next one would be many to many relationship. Okay. So in the many to many relationship, we have shop one and we have fruits, right? So if shop one and here we have shop two and here we have vegetables. Ignore the spellings. So you can see one shop can sell vegetable and fruits. Also, fruit. This shop too also can sell fruit and vegetable. So means this fruit belongs to both shop and this vegetable also belongs to both the shops. Whereas this shop contain two thing and this shop also contain two things. So what does it mean by this? Pretty simple. One model can have relationship with the two, and here also one model can have relationship with two. So this is called as a many-to-many relationship. Similarly, we have to create here. Like if you are thinking account type, like there is a null, so you can create the relation. You can create the relationship, but it will throw you error. Like the filters will not work. The filter will not give you the accurate answers, right? So if you are making the relation between account type and hierarchical path, and then if you are designing for many to many, see the relationship identity is many to many that would be used. It is expected that neither column this and this contain unique values, right? Next one, many to one and one to one also there. So next would be what is the difference between single and both? Single and both means if you are selecting the single one, which means here you can select something in the filter, it will impact. But if you filter here, this will not impact, right? If you are selecting both, which means if you are selecting here, this will impact. If this will select, then this will also impact. Both table will impact with the selections, right? And but for the single, only one will impact. Next one will not impacting anything, right? So let's moving to this one. You can see star is there, which is many, and one is there for one, right? When you double click when you edit click on edit relationship, you can see general ledger we have account key, and in account table we have account key, and this relationship is many to one with a single, which means anything if you are selecting into the table, whatever, like mostly in the dimension tables, which is the account table, if you are selecting any account key, this data will differ, right? The next one is general ledger and department one. So here you can see there is a department and department. This is also single, many to one. So in the fact table, we have many columns will be changing with the respect of single department, right? Now, next is general ledger and organization. So here also you can see many columns of general ledgers with the same organization. If you changing organization with respect to this dimension, many columns, or you can say all column will change based on the single organization word, right? And the last one would be general ledger and scenario. So in the general ledger and scenario, if you are changing something into the scenario table, then automatically the general ledger will change. This we called as a relationship, and here you can see cross filtering direction and card identity, which kind of card identity you require. Clear? Any questions? Anything? Okay. So let's move further then. Load and transformation data for the data modeling side that we did yesterday for the shaping of the tables, right? Database normalization. Many times we learn this and we hear this word. What does it mean by this? Basically a set of logical rule and process to follow the data modeling, right? Some set of rules would be there, like organizing some database, and if you want to remove some redundant data, archive or design, which is the good representation of the real data. Tables are connected through relationship in the Power BI. This is the normal thing, right? That is the reason we called as a normalization. How do you are connecting your one table to other? How do you are changing some data into other? How do you are managing your data one into other? So this way act as a you can say relationship models, right? So data shaping in Power Query, mostly in the data shaping side, what we will do is column splitting, column extraction, query merging, and query appending. With these some techniques, we will do the normalizing the complete data. When the data normalization done, with the Power Query, you have done the, you can say, um, the basic structure, or you can say the model is done, right? Then we can go further and see what we have in the database, right? Let I am giving you one example. Like in the C2, C3, C1, C2, C3, C1 we have 1, 2, 3, C2 we have 2, 3, 4, and C3 we have 3A, 4B, 5C. And you are thinking that we have to split this into two. So it would be like 1, 2, 3, and A, 2, 3, 4, B, 3, 4, 5, C. So two table, this C3 will be splitting into two column, which is C3 and C4, so that it will be easy to understand, right? Now, how can we split? Like based on delimiter, based on number of character, positions, lower, upper, digit, non-digit. You can do any kind of a splitting based on this, right? In this case, it is a digit and non-digit kind of a splitting. The next would be the column extraction side, right? The column take from one table, break them into another table. That is our mostly cases we are following, right? So suppose in the first table we have K1, K2, K1, K1. Values are value 1, value 2, value 1, value. If you are thinking that this would be extract and like making the separate table, that will make a sense. So we can do key and values. So K1 is V1, K2 is value 2, right? And the old table would be exactly same. It will not differentiate or it will not change anything. Only the value column will be removed from that table and moving to the next one, right? It will make you the sense. So the result will be keep the distinct row, shrinking the total data, and then reducing the redundancy. That would be working as a normalization, or you can say working we are using with the normalization term. Now query appending. Query appending side, there are two tables, C1, C2, C3, and the second one is C1, C2, and C4. Now, what we have to do is we have to combine this. Now you can say merge them or you can say append them. So combining of these two tables containing very tricky, because if something would change, all data will be changed in the modeling side. So what we are doing is right now we are using the union all statement, so that C1, C2, C3, and C4 would be there. If something would be not there, automatically it would be a null. Else the value would be changed, right? So we are appending these two tables. So here the row values is matching based on the column name. Whatever value is not there, just putting the null. Now next is equivalent to the union or. That is very important. Query merging. Difference between append and merging, that is very important. You have to make sure what you are doing. So in the merging side, it would be a join together with the table based on some value or some uniqueness or some keys, right? It can be inner join, left outer join, right outer join, full outer join, right? Suppose there are two tables, column A, column B, column C, and key. Second table is key and value. So if you are merging this with inner join, you can see key 1, value 1, key 2, value 2, key 1, value 1, right? If it is left join, then key 1, value 1, key 2, value 2, key 1, value 1, key 4, null, because this value is not exist in second table. Full outer join means key 1 value 1, key 2 value 2, key 1 value 1, key 4 null, key 3 value 3, right? So remember, whatever join you are doing, inner join will give you only limited data, left give you data based on your left table, full outer will be giving you whole data combined. So in the full outer join, most of the cases, it will give you some duplicate data as well, right? So let's practice this first, and then so for this we have to go to this transform data. click on transform. Once you click on transform, you can see, okay, some path is not there. Okay, so let's download from internet. We have internet for that. Don't worry. Sample, or we can create right now. We can create. Don't worry. Let's create one. So let's create a simple stuff in this one. We have student ID, student name, marks, and let's say class ID. So student ID is 1, 2, 3, 4, and so on. We have till 10, and we have like John, Mohan, Randy, Shiva, Rahul, or something like that. Uh, yeah, or okay, 6 is enough. Mark side we have 60, 71. Class ID side we have suppose A1, A1, A3, A1, A1, A3, A2. Okay, and I'm saving this. Saving this desktop as class. Okay, now I am creating one more with class ID, class performance section. Class ID is same as E3, E2. Class performance is 85, 96, 45. Sections A, B, C. Okay. Now let's load this data into our way. Blank report, get data, desktop, class, and section. So one by one we have to pick. Load again, get it. Okay, let's load it. Loading one more. Now you can see the data is successfully loaded. So here I'm putting class. Here I'm putting. So first of all, we have to go to this table view so that we can see everything would be there or not. Class and section. Now, when you click on relationship, most of the cases automatically it will detect the relationship and create. See, this is the new one, but it is automatically the relationship and create. So once you have to confirm whether the relationship is correct or not, you have to click on manage relationship. Let's delete this relationship so that we can create a new one. Then creating a new relationship. Now first side we have chosen class, second side we have chosen section. So we can see class ID and class ID. So first one is acting as a fact table, foundation one. Second one is acting as a dimension table. It is only containing some information. So that would be many to one relationship. Do we need in both direction or not? It's up to us, right? We are okay with the single one, then we can choose. But I want both. You can click on both and see. So the arrow here in the in between mid, you can see the arrow would be looking like a both the direction. Now this one is created. So if you create, suppose you are creating some bar chart, right? If you are creating a bar chart based on marks and student ID, oops, reverse. So you can see we have five, right? And if I want to apply a filter based on student name, and if we change to Priya, this was 5, Mohan, John, Rahul, this is changing, right? But I want to change this based on section. If I would choose A, it is going 3, B for 1, C 2. And C, if your relationship is correct, your data is showing correctly. That is the impact of data modeling, or you can say whatever model you are taking. With the two tables, it is pretty easy. I know with multiple tables, you have to create same logic, right? So if the data modeling is not working properly, then you have to go to the transform data. And if you are thinking that there would be some sort of a changes like a splitting or something, so you have to click over there and then transform. And what kind of a transformation you want, you can go with it, like splitting or formatting or something, right? Make sense? Let's do one more thing, right? Let me open the class. So I will give you one more demo for the name wise. Like suppose this is student first name, and there is one more table which is student last name. By default, if you are getting the data, John, Mark, Mohan, Verma, Andy, Lynn, Sharma, or Singh. Okay. So now, if you are getting the data in this format, then what you have to do is refresh your data again. It will throw you error that there will be no column at this, right? So what we have to do is we have to load a new data because this will throw you error because we have changed the column, right? So I'm doing what? I'm removing this table and getting the new data again, changing name to class, going to home, then transform. Now I want is the full name column instead of this. When you click on this, and if you want to join these two, right? What we have to do is we have to merge these two into one. This we can do using what? Either you can do with calculated column or you can merge with, oh sorry, merge will not working, apparent query. Apparent also not work. So mostly we have to merge through the calculated, I think, conditional columns here. So in this conditional column, whatever column you want to create, it will be there, right? For this merging, you have to create using the concat kind of a function, right? So if you want to merge this, then we can do this like conditional column will also not work here because conditional column is based on whatever value you have, right? So what we have to do is we have to do a merge kind of a condition required for this, right? So here we can do directly, not required any kind of like the value column or some other. Let's see, we have concat or something. Okay, concat list of values we have. So la instead of we it will not work. Okay, let's do then condition column. I don't want to show you that, but let it be. There would be a column called as new column. When you click on new column, whole name is equal to concat of the table name, which is class, then first name, comma, last name, bracket close, click on right tick, then when you go to table view, you can see there would be a full name, but there is a challenge. I'm not able to see the space between this, right? So for this, what we have to do is, comma, instead of this, we have to put concat x, and in the expression, we have to put space class. Just a second, it will. Okay, it will be throwing a continuous name. Just a second. First name, not taking space between this. Okay, let's see. We can do, don't worry. So before that, like if you want to apply one more filter over there, you can easily do with the full name. Right now, this full name will be showing you here. The space we can do easily, don't worry. So when you select something, this will work in the data modeling side, right? Let us do one more thing. Create one more Excel table. That we will cover in the next one. Don't worry. So suppose you have one more table which is containing student ID and then fee remain fee. Okay. Let us see the data into class. Okay, 1 to 6. So you have one and fees is 250, remaining one is 100, two, 300, remaining is 50, three, fees is 500, remaining is 60, 4 and 5 and 6. Here 100, 900, 600, 100, 150, 600. Okay, let me save this again. Let me go to get this new record. P. So consider to be three tables. One is the section one, second one is the class one, third one is the piece relative. Right. So in this one, let me go to the modeling side. Now you can see it is not okay. It is also again able to access, able to see the what kind of modeling is required. Let me go to this. Piece side you can see it's creating one to one. I don't want this, so I'm just deleting this so that we can create a new relationship. Above side I'm doing class, second one is fee. So based on student ID, automatically it is selected, is creating one to one. I want this to be many to one, right? In the both direction and then see. So here now you can see here it is automatically star and this is the one. This we called as a star flag schema, right? So it is covering with some look like a star when you are getting multiple tables. Now you are creating one more circles, not circle, line chart for every student, or you can see student first name, let it be and you are taking fees, uh, not count. I want the sum. Okay, first instead of first name. Okay, okay, okay. Let's see the bar chart. Now you can see based on like if you are selecting some name, the values. See, and continuing all, and then if you are going, then you can see how many keys is there, and this is working with sections as well. So if the relationship is correct, the model will give you the correct information that you want, right? So this is the complete overview of this. Let's see for the next one. Kimball model. It's look like a star plug schema with one fact table covering multiple dimensions, surrounded by multiple dimensions. Just like property on sales and dimension side, we have date, salesperson, payment type, property, right? So it is a star flag kind of a schema using for the data warehousing, right? Next is fact table. So here the fact table means the main table which is containing the measurement or metrics from your business perspective. Keys are mostly it contains sales data, mostly 90% cases used to establish the main relationship between them. Fact tables are long. It can change every time. Fewer column, but lots of rows. Look like this, like lender ID, date ID, property ID, payment ID, salesperson ID, rent and durations. That is the second one, the established relationship we have to create, right? So first key is establish relationship between the tables. Second key is metrics from the business process. So here you can see lender ID we have to create, start date we have to create, property ID, payment ID, sales ID. This is not the part of the sales table. This is only for creating the relationship. The data which this table have is only rent and duration. Measures, or you can say rent or duration, is act as a measure table, or no, sorry, measure column. Now dimension table. If you want to know that which one is the dimension table, just ask who, what, when, where, why. That's it. When you ask a question, who is, when is, where is, you will get the information from these tables, right? Mostly it contains person, employee, customer, vendor data, contains some name, date of birth, height, weight, or something. Few rows, but lots of columns, right? Example, sales ID, first name, last name, date of birth, salary. It is containing some information based on person ID. It can be static most of the time, right? Like suppose if you had someone, that person cannot be changed till 1 to 2 year, or 5 years, sometimes long. Next, you can say only one column is the identity of this. Rest of the column act as the attributes of this table. Now this is the whole model. Look like a star, so that is the reason we can say this as a dimension. Or sorry, you can say the star flag scheme. The data set. Establishment survey, it contains number of employees, number of firms, and in the dimension side, it contains NISA, industry group, subsector, sectors. Time side, it is showing you era, decade, century. Age side, it is giving you establishment. Age, geography side, it is giving you country and state. So this whole thing will be acting as a data set. Whatever data you have, it is a combination of fact and dimension, right? We have already did this practice, and we have created this star schema as well, right? This is the one star schema. The fact table surrounded by multiple dimension table is called as a star schema, and a snowflake schema is if you have lots of table and one dimension table is having relationship with the other, that we called as a snowflake schema because it is dividing into multiples like a branch, right? But the sales table is same. or you can say the fact table is same, right? Here is the some closer look. So a star flag schema, it contain only one dimension table like this product ID P1 having name, subcategory and category. That's it, done. Whereas snowflake schema, one dimension table having product key as well as subcategory value as well. Then sub to subcategory as well. So child, then child. So one product category P1 gloves having S1, whereas subcategory S1 having hand and foot and computers or something. Then this is clothing and electronics, right? So most of the cases, why we go with which one? So star flag schema will preferred for the approach easy for the small business. Most of the Power BI tool is using this one. Snow flag is for the less duplicate records, some big data warehousing, updating the records in more efficient way, but it is a very big one. So most of the cases it contains lots of tables, right? Sometimes we have to combine both, right? So both schema work, but Power BI prefers star flag schema, easy to understand, perform very less and easy content. So this is the whole thing, and once everything would be done, like whatever models you have created, everything would be done. Then what we have to do is we have to go to the performance analysis so that we can analyze our performance, whatever model we have created. That is how much it is successful, how much it is taking a time, how much we can reduce the time effort, and then how we can improve our model, or you can say measures or slicer, or how much refresh rate is not taking that much time. So we can go with the performance analysis. It will give you some sort of advice as well as tune our DEX query, as well as improve data loading, complicated visual. How can we simplify this in the simple manner, right? Number of visuals we can add or this kind of stuff. Okay, let's do this again. So how do we this the performance? Once you click on the, you can see uh, optimize side. Here you can see all the visual is already being created. Then in the performance analyze, you can see this is the one. Start recording, refresh visual. Now you can see the slicer is taking 133 millisecond, 6 millisecond, and see the DEX query is taking 6 millisecond, visual display 33. Now sum of marks 194 millisecond. This DEX query is taking 9 milliseconds. So you can see here, right? If you want to improve the queries, then with this number, you can see like which one is taking more, then you can change the query based on your requirement, right? Even you can click on this and then you can see which text query is already being there. And if you want to change something, you can do, right? So this is called as a performance analyzer, sorry, so that we can do some sort of a changes based on our requirement, right? Now moving to the last topic of the day, which is defining and shaping the table. Basic data modeling concept. Second, load the performance analysis with Power Query and Power BI. Merge and append the table. That is the main key point of your complete end-to-end schemas. And also we have to use Kimball model, fact dimension, star schema, snowflake schema. So most of the cases, do these three steps. We can easily modify or check our data based on our requirements. We will create a beautiful report as per the requirement. Okay. Okay, guys, if you have any questions, you can ask. Okay, I don't think so. You guys having any points? So let's close the session, and in the next Saturday Sunday, we will cover the remaining topics for the further enhancing our knowledge on the Power BI side. And let's see for the next one what we will learn and what we will be doing for the next session. Okay. So thank you guys for joining the session. Thanks everyone. Nirupama, if you are talking, you are on.
Oh, yeah, Saurav. I don't see any questions right now. I just wanted to check that. Uh,
Okay.
all right, we'll see you next weekend, and thank you so much.
Thank you, Nirupama. Thank you, everyone. Let's see in the next lecture, Saturday, Sunday, 4 to 5. Okay. Thank you.
Yes, 4 to 5. Thank you.